And as with everything else that we've been talking about, penetration testing, it might be a important, valid technique when we use it for good, when it's being done by security professionals trying to assess how strong protection is on a network or on a system. And it's, of course, also bad when it's being used for crime or for malicious intent by attackers and cyber criminals. And so with penetration testing, like with anything else, we want to look at what could be the remediation. And one of the first things we'll talk about is honeypots, which is an old slang from espionage. And I'm not sure how far back it goes. It might be the Cold War. It might be before that. But essentially, it's part of spycraft. And what it means is that we are placing something to deliberately mislead or to trap someone who is looking for information that they shouldn't have. So just like there used to be honeypots that trapped potential spies and secret agents, in the modern world, we can place a honeypot in our infrastructure that will trap potential attackers or potential scanners that are looking for information about how they can penetrate our defenses. And so what this involves is really having a piece of infrastructure that's dedicated to cataloging any kind of requests or scans done against it, or anything where it's either actively or passively trying to get in, and then either just cataloging that for later and alerting the security professionals that something happened and who tried to do it, or perhaps even it can try and delay or disable the attacker, the penetration tester, and provide them misleading messages about what they're connecting to, and send them invalid data or send them on a bunch of redirects. And all these things can actually be honeypot features. Sometimes it'll try to actually download something to the attackers to kind of reverse the attack. And to go with that, we can always have not just the honeypot, but our main network access layer. So suppose something like on the firewall or on a proxy, have something that will do a deliberate slowdown in responses if it detects that the request is part of penetration testing or part of unusual activity patterns. And this is where we can definitely be a little more cautious, just to make sure we're not messing with our main business activity or our main personal activity. We just need to make sure that when we introduce these deliberate slowdowns, they are really targeting penetration testers, especially the ones that we don't want to be penetration testing our systems and aren't affecting regular traffic and regular use of the systems. And there's also a similar and somewhat tricky technique, which is message and traffic masking. And what this means is that, or suppose there's some kind of a standard vulnerable application or service that a penetration tester thinks they found, and the way that they know that they found it is because when they hit it, with the request, it'll send back a standard welcome message or a standard error message or something. And if we change that application or service to send back something else, now the penetration tester, especially if they're just using that message to figure out what is what, because sometimes they're working without advanced knowledge of the system, especially if they're doing it legally, they might think that they stumbled across something completely different from what they are looking for. So suppose if they were looking for Nginx, we send them back a request that has headers for Apache. And we can mislead attackers, but especially important, like with everything else, that we don't do this for legitimate use cases. And that's what makes this technique a bit tricky, is we need to make sure that, and in security in general, this is really one of the difficult things, is to make sure that legitimate use does not get hampered by trying to defeat illegitimate use or trying to prevent attacks or abuse of the system. And traffic masking, it goes back to the same thing at a lower level, where if somebody is listening for particular kinds of stream of packets, or expecting to see a particular port or a particular IP respond in a particular manner, if we can have something in front of it, like a proxy, that actually changes the nature of the packets, changes what's in them, or changes how they're sequenced, or changes the address from which certain things are coming, or ports from which certain things are coming, like suppose not using 22 for SSH on that endpoint, that is going to make it harder for penetration testers to assess how vulnerable a system is, just because they are getting a less clear picture of what is behind the firewall or behind the proxy. And that means that they now don't know how that they're going to attack it and find vulnerabilities. This is sort of like, imagine that you have to open a door in complete darkness. And so if somebody is coming in and they're trying to pick a lock, now they have to pick that lock in complete darkness. Or even worse, it's you put like 5 different doorknobs onto your door, and only you know which one of those is the actual doorknob. And other people who are trying to just get into your house by just jiggling the doorknob and seeing if it's open, they're going to have to jiggle 5 doorknobs now. Now imagine on top of that, that one of them is electrified, and you see where I'm going. Penetration testing is similar, where there's a lot of trying things, and so if there are countermeasures to it, sometimes they can confuse, delay, distract, or disable the attacker. And that's also where we come in with targeting testing tools, and this is what I was talking about with having a specific strategy around identifying who is attacking you, or who is penetration testing against you, versus who is just trying to use your system legitimately. And so if vulnerabilities have certain signatures and certain patterns that they emit, so do testing tools sometimes. So if we know that people are using particular standard testing tools, or tools that work in a certain manner, if we detect requests and signals that match that pattern in our infrastructure, we can then identify that some kind of an attack is going on, or some kind of penetration test is going on. So we can, suppose, look through our web server access logs and see that certain kinds of requests with certain kind of headers, or certain kind of user agent strings, or certain kind of payloads are coming in. Then we can say, okay, this is probably part of the attack proxy, or some kind of OWASP Go testing tool or something, right? Like one of the big standard tools, something built with Metasploit. And if we can identify that, then we know that, yes, this is an attacker, and we can disable them or do any of the other countermeasures. And those are some of the ideas around preventing penetration testing, especially when it's not being done on your behalf.